just before you open this or do anything, this video is only for entertainment purposes. If you're not a Kenmore repair person, then you shouldn't undertake this. There's 120 volts. This controls 120 volts, which can injure or kill you. So don't take this lightly. Okay, this is part 2. I'm tracing down an electrical issue with this Kenmore foot activated speed control for an older Kenmore model machine. I'd done this yesterday, found no continuity whatsoever. Everything seemed to be just fine. I'd replaced the cable because the old one was all, repaired with all sorts of electrical tape and seemingly frayed. So then after having no continuity while not plugged into the sewing machine between neutral and hot, I then tried plugging it in and it ended up giving the same spark that I was encountering at my sister-in-law's place. You can see how it tripped the breaker and made the connection there. So I'm not sure what's going on. I think I need to take it all apart and not just trust that when it's working in one spot that it's going to stay working throughout its operation with or without the cover on. So let me just see if at this point we have continuity between hot and neutral that we didn't when I reassembled it yesterday. So the ohmmeter is on, the multimeter's on ohms with the signal, and yes, I'm getting connection. It does make me wonder if it's the cover, because I was doing all the checking with the cover off, and silly me, I did not check it after putting the cover back on, and maybe there just isn't enough space. So let's look at that first. If you watch the other video, you know the cover is a very tight fit and just almost exactly the size of the box underneath. I don't see any place where there was a connection or a spark, but it did happen at the plug. Let me try this now and see. Okay, so we still have continuity, even with the cover back on. So that makes me think it's something underneath this that I'm not seeing that is connecting, allowing neutral and hot to connect. It's interesting, this is not grounded, so I'm a little confused because this box should be fully isolated from everything else from this ceramic device. The issue is that there's a connection between the neutral here and the hot. I don't think it's right there. It could be, but I don't see any connection. I've got a jacket here. Before I take it apart, let me just take off this item. All right, going back to the, okay, so it's not that. What I will do is I'll push this sleeve up further to fully cover that neutral there, just so it has a little less of that exposed. But let's disconnect the box itself. That's too large. these screws connect to nuts that are held into fitted place in that sort of ceramic or insulated box. So with that, I think I should be able to pull this out. There may be a need to disconnect to bend that. This is under some pressure on this spring, perhaps. Definitely is. Okay. So those are disconnected. Just bend this up. I should be able to lift this out. All right. Where are you, voltage leak? I don't see any burning in there. I don't see any obvious place where the metal is projecting below. Must be somewhere here. Must be somewhere here. I wonder if I'm not entirely sure if that's the source of the problem, but it seems to be extremely likely. This, I was saying that was not an insulator before. There may have been a bit of a cord there. I mean, sort of like jute twine, which is sometimes in here, but you can see that these are missing their insulation and are kind of right up against one another. So this is clearly the place where there was a problem. So I'm going to take off this clip. I'm going to go back, see if I can get to good insulation, and then replace these ends. I think that is likely to solve the problem. All right, so I do not feel comfortable using this wire. I'd have to shorten it, and even here it's extremely crumbly on the insulation. So I need a new three conductor wire, probably 16 or 18 gauge. I have a bunch of these cables. Don't use them very often. That's not as frequently the 3-prong connector. And this is 120 volts, should be plenty beefy in terms of the gauge. So I will be sacrificing this and using this, provided it's long enough, I'll double check, using that as my 3-conductor connector to replace the existing wire. Okay, that was a very successful trip to the basement. So you'll recall I was kind of seeing if I could shorten this cord, but finding that it was the insulation was fairly deteriorated at one end. It was successful, and then I was able to put a screw down on these little end terminals into a piece of wood in my vise, and then use a small awl and a hammer to open up the crimp. These are smaller and a different shape than any type of end terminals that I have in my kit right now. So good to have 6 of those. But then I also found that the wire itself, I thought there was only this end of the plug that was really bad. Yeah, I showed you the deteriorating insulation a minute ago. This one looks so much better, and this is what fooled me originally yesterday, saying, oh, insulation's in great shape. Turns out this is just heat shrink tubing that was put on at one point over what is deteriorating insulation underneath. And so look at these, all these contacts could easily short out, which is why I tripped my 20 amp circuit this morning. Clearly something had shifted. Anyway, I'm really glad I'm replacing this wire. I probably should have done it from the outset. But there'll be all new wires except for the wire in the machine that goes to the motor. I don't have the machine with me now, so that's a different question. But anyway, these things were pretty well toast. I'll have to figure out strain relief because there's no room for underwriters knots anywhere. They used clips and other things. So anyway, I'll work on that. But I need to start assembling the replacement for this piece with the white, the black, and the green wires using my grounded plug wire, which is plenty long and plenty good gauge. All right, well, I didn't record this because it took some fiddling getting these things crimped down appropriately on the wires, but I did get that done. So now I have black, green, and white, which will go to black, green, and white in this plug using the same crimp approach. To get these out, I used an awl and a vise. I think I mentioned that before. So anyway, this part I'm going to seal up. I've done the continuity and all is well here. There's no connection between neutral and hot that was causing the problem before. And then we'll do the connection on that, and then things should be good to go. All right, now I'll be doing the assembly of this plug, similar to how I did the other, so I'll show you here, but I've got my black, white, and green contacts there that'll do, that are appropriately connected over in the box. I'm gonna crimp on these three items. I've got the wires cut and a strain relief. I was able to use all the existing strain relief, which was pretty nice. So let me connect a white. Down. Okay, so all three of those are on. Shifted the labels here. Oops, let's see. Little tiny strand of copper that I'm just gonna snip off there. Wouldn't have likely connected, but just to be safe. Connector for the green one in the middle. Whoop. Oh, that's all right that comes out because it's held in by the top cap. Right now they're just really sitting in here, maybe barely pressure fit, but they kind of fit into a slot. And then this right here, this metal crimp is on there as a strain relief. There's a bit of a band, you can see it here as well, that helps hold that. So get those into place. Put this on down, make sure the strain relief is on the inside, which it now is. These two squares hold the nuts. The bolts come through on the bottom. Let's get that to catch. Put the other one on, and then I'll tighten them down in a moment. Okay, so tighten these so they're snug. So at this point, this is what plugs into the sewing machine. And this clips on the skirt board that does the sort of rheostat dimmer speed control. And this plugs into the wall. So now I'm going to go back and do the test I did yesterday with my multi-tester. Now that I've replaced the really, really flawed wire with a crumbling insulation. So, in terms of resistance, right now that's an open line, no connection, no voltage, no electricity flowing at all. There's no resistance there. What we want without the sewing machine connected is to have no connectivity here. Thank goodness I don't. What I'll do is try some of these and see if I get continuity. So the neutral, not exactly sure which one this connects to here. I believe it was the green. Yep, good there. The hot should connect to, I forget which one of these gets constant power and which one doesn't, so I'll try each. Okay, so there's the hot. Nothing there. Continuity. What I should get here is, watch this, variable amounts here. Okay, that's working right. It's a little fiddly just because the contacts from where I'm connecting aren't great. So this is good news. There's no short anymore. We won't have that sparking and blowing of the circuit breaker. We've got constant power, hot going to here. We've got the neutral coming to here, so both of those stay connected to this. And then this is the variable one that controls the speed of the sewing machine. Everything has good strain relief from the original parts. This may be an inch or two longer, but again, it's just getting duct taped up under the skirt. So I think that's okay. I didn't want to make it the exact amount, especially since I don't have the machine here with me. So with that, this project, even though it was in two segments, is done. Here was the real problem child in all of this, basically failing insulation on all three connectors so that anytime there was a little bit of movement, these were touching and shorting out. So we'll say goodbye to this cable and bring this back to the sewing machine at some point. All right.